is Murray Stardom, and this is a presentation on flipped classroom technologies and a few activities related to them. The first question is, what are flipped classroom technologies? A flipped classroom is an environment in which the typical classroom work of knowledge acquisition, where the teacher is lecturing, that is done as a video created by the teacher usually for students to consume at home and write notes. And then the typical homework is done in class, supported by the teacher and other students. So one of the technologies is screencasting, which is a method that teachers use to record lecture content for students to take home. Now in this lesson I have students creating them themselves in the method of creating a tutorial for each other that they're going to use for a final product. So the inspiration for this is a website called mathtrain.tv, which is a website where students create screencasts of math problem-solving skills for use by other math students. The first step in this is in my grade 12 media portfolio class, I have students investigate a piece of software that they've never used before. Very rarely do high school or really any students use Adobe Illustrator, and there are a bunch of applications that we use it for. So students are encouraged to develop questions about the software and make a plan to figure out how they're going to use the software from online resources, forums, YouTube tutorials, things of that nature. So once they've learned how to do this, they use a piece of screencasting software. Now I've got an image here of Camtasia being given its due respect, but there are a lot of other things on the market that are free. And so what they do is, after they've learned how to use the software or a lot of different things within the software, they create a screencast of something valuable that they learned how to do that they want to pass on to other students. Now, afterwards, students review their own screencasts that they've done, as well as review those created by other students. So this allows them to be critical about the actual presentation content, as well as by doing this, they're identifying different skills that maybe they didn't know beforehand that they'll be able to share and use for a final project. Step 4 is I have students create a final project. Usually I do a poster of some sort, and in this case what they have to do is they have to use the skills that they learned how to do themselves, and they also have to use content from their classmates' screencasts to do some different things when they're creating their poster. The most important part about this is a reflection at the end that students describe the process of learning how to use the software. So they need to document resources that they've used. They need to do a critical reflection of their own screencasting content after getting some feedback, and also they need to document other students' screencasts that were useful to them when they were creating their final project. So the benefits of doing things in this way, I do things like this but without screencasting currently. The first thing is that screencasting is fairly intuitive to students. Currently I've been doing this same thing with a website, but students have all kinds of problems if they're not terribly familiar with websites or even computers. Creating a website that shows how to do these things, and also, you know, I have them do screen captures, so just images of what's happening on the screen, but sometimes the text that they write doesn't really fill the gap between one step and the next. The second thing is it has a much lower anxiety level than actually doing a presentation on any content. If a student can create a recording or a video of something that they're trying to present, then they can be a little bit more focused and natural than if they have to stand up in front of the class and show what they did. It also is an example of multimedia learning, so we know the benefits of learning through multiple channels instead of just text and images. This provides audio, it provides animation, which really helps students learn the content. The content that's created by this is very portable. It's easy to move one video file around as opposed to a website with all kinds of files that need to keep their structure. And there are also other problems when moving websites from one computer to another to share this with other students. In addition, the video content is a lasting artifact that can be kept and easily shared with future classes. Students can even put this content on YouTube and not just teach future iterations of your class, but anyone on the internet. And I have a lot of students who have their own YouTube channels, and there's not a whole lot of useful stuff on there, but they do like checking how many subscriptions they have and putting some software tutorials or really anything, any content of value is of benefit in that regard. And then finally, they learn a lot through the production process. When a student is writing something in a website format, they're just sort of doing it as they go, not really thinking about the plan and then looking at what they did after the fact. But when you're doing a screencast, it really helps to be thoughtful about what you're going to show, putting together a script or a storyboard, and there's a lot that can be gained through this. And this kind of activity is appropriate for any class in which a final presentation is done. I mean, the final presentation could be a screencast of a PowerPoint slideshow. I mean, any subject area can benefit from this kind of activity. And in my second lesson, I've defaulted to something that I really enjoy content-wise, is in my computer science class. When I've taught this before, I like spending some time on sorting algorithms, but there are a few problems currently with building in enough time for lecture content in that class. So the rationale for doing things in this way using a flipped classroom model is so that students can actually do something at home, because right now there's no guarantee that students will have the same pieces of software that we're using at the school. There are a few that are kind of expensive. I know things could be done using some free programming software, but it's never a guarantee what students have in terms of even what platform they're using at home. And in this way, if you have video content, it can be shared on YouTube or as a podcast. So if students have devices that can access those, that's fine. But you can make different adaptations for students who might not be able to access that, like the video content could be placed on a DVD, or there could be open lab time where students can come in early or stay late after school. Either way, it allows content from a class to be done outside where that couldn't typically happen. So the first thing that I do is I would assign a lecture on sorting algorithms and provide students with a note-taking frame with some additional questions at the end, just to get them thinking and expand their thoughts around the topic before we deal with it in the next day's class. When students come to class the next day, it should start with an entrance activity to review the content that they should have looked over the night before. This is also a benefit for the students who viewed the content, but it also helps for students who didn't view the content and then need to sort of be brought up to speed with what is happening, as well as students who viewed it but didn't understand and have questions. This is a perfect time to go over that and give them feedback on their thought process with the content. And in this, I like to do some hands-on activity, which using screencasting can really help, because I don't have to spend class time on all of the lecture stuff, so I can do some more active hands-on activities. So I have them do an egg sort with some numbered eggs and have them record step-by-step the actual process to sorting them. Afterwards, students compare their results. So if students understood the sorting algorithm, they should be able to follow step by step what they need to do to get the sort done. And if it's different from another student's, then you know somebody made an error, if not both groups actually. So this is a good activity to have them try and diagnose the error and problem solve through these different sorting methods. The last thing that should be done after all of this setup is the actual programming using them. This is really useful because otherwise sometimes students just learn these sorting algorithms by rote. So they can replicate the code for them, but they can't actually understand the content for future activities in which they need to apply this content. Benefits of doing things this way in the flipped classroom model is you get increased one-on-one time with your students, which students certainly appreciate. I know in some content-heavy courses there's never enough time to spend time with your teachers and ask questions. Well, in this scenario there actually is. The next thing that is really useful is they also have increased collaborative time, so there are other students that they can work with and use the benefits of cooperative learning. The feedback in this situation is also more immediate. So rather than a student who does something at home incorrectly, could either have a habit set or they have to wait for maybe over a weekend to find out what the correct answer was or what error they made. In this case, it's actually immediate, so that if they make a mistake on the first question, you can correct it and then they can do the rest of them correctly. It leaves more time in class for application because the content or the knowledge content is covered at home. Students can spend more time with hands-on activities in class. The content can be rewatched as well for students who are absent. They can watch it while they're away. Students who need to review the content can look at it again.